the key to our work with fractions is going to be the fundamental principle of fractions, which I'll write down for you now. Okay, is it A times K divided by B times K is equal to A over B, where we'll assume here that B and K are not 0. Now let me explain the fundamental principle in words. If you start with a fraction, say A over B, okay, if you multiply the numerator and the denominator by the same non-zero quantity, K, you get an equivalent fraction. In other words, A over B is equal to AK over BK. On the other hand, if you start with this fraction here, if you divide numerator and denominator by the same non-zero quantity, in this case divide numerator and denominator by K, or as we say, cancel the K's, then you get an equivalent fraction. Now when you use the fundamental principle of fractions in this direction, that is, you divide numerator and denominator by the same non-zero quantity, okay, we are reducing the fraction. Okay, using it this way, we are reducing the fraction. On the other hand, and this, by the way, is what we're going to be doing mainly in this videotape on multiplication and division of rational expressions. On the other hand, sometimes we have a reason to use the fundamental principle in the reverse way. Okay, start with a fraction and multiply numerator and denominator by the same non-zero quantity to get an equivalent fraction. Okay, we build a fraction. Okay, this is called building a fraction. We usually build a fraction that has a larger denominator. Okay, it's not in lowest terms. But we'll need this for our work in addition and subtraction of fractions, which is the topic of the next videotape. Okay, so using it in the reverse way, we call that building fractions rather than reducing fractions. Okay, let me give you some examples with numbers, and then we'll move into algebra. Okay, and all our work with fractions, we would like our answers to be in lowest terms. That is, the numerator and denominator of the final result should not have any factors in common. If they do, we would cancel these factors out. That is, divide numerator and denominator by these factors. Okay, let's look at the fraction 24 over 36. This fraction is not in lowest terms. Okay, there are factors in common. You might say, well, the 24 is 2 times 12, and 36 is 3 times 12. And using the fundamental principle of fractions, it is perfectly okay to divide numerator and denominator by 12, or cancel the 12s to get 2/3, which is 24 36 reduced to lowest terms. There was 24 over 36. This was not in lowest terms. They had a factor in common. The greatest factor that they have many factors in common. For example, 2 goes into the numerator and the denominator, so does 4. Okay, what we're trying to find was the greatest common factor. Okay, in that case, it was 12. Okay, usually we write it like this, 24 divided by 36. How many times does 12 go into 24? It's twice. How many times does 12 go into 36? 3 times. 12 goes into the top and the bottom. So we divide 24 by 12, we get 2. Divide 36 by 12, we get 3, and we get 2/3. By the way, you don't have to do it all on one shot. Suppose you notice that, let's say, 4 goes into the numerator and the denominator. So 24 divided by 4 gives you 6. 36 divided by 4 gives you 9. Then you look at 6/9 and you say, well, that's still not lowest terms. 3 is a factor in both the top and the bottom. 3 into 6 goes 2 times. 3 into 9 goes 3 times, giving you your final answer of 2/3. So if you don't happen to notice the greatest common factor, okay, well, then you can just pick out any old factor, reduce it, and then see if you can possibly reduce it again. Okay, now let's try an example that has variables as well as constants in the numerator and denominator. 15 x squared y cubed over 6x cubed y squared. Okay, what we're going to do here is first work with the constants and then work with the variables. Let's look at the 15 over 6. Okay, that's not in lowest terms. There are factors in common. 3 goes into the numerator and the denominator, we say we divide 6 by 3 and we get 2, divide 15 by 3 and we get 5. Okay, so we've taken care of the constants. Now we look at x squared and x cubed, and we notice that x squared goes into both. Dividing x squared by x squared, we get 1. Dividing x cubed by x squared, we're left with an x. And now on the y's, dividing y cubed by y squared, we are left with a y. Dividing y squared by y squared, we're left with a 1. For a final answer of 5 times 1 times y, or 5y over 2x. Okay, by the way, the important thing here is that we were dealing with common factors. We were canceling out common factors. Everything here, notice, was joined by multiplication. Let me show you another example. X squared plus 3 over 3x squared. Here we cannot cancel the x squareds. We cannot cancel the 3's. It is true that 3 is a factor of the denominator, and so is x squared. In other words, it's 3 times x squared in the denominator. 3 and x squared are factors of the denominator. But neither 3 nor x squared is a factor in the numerator. They are terms of this polynomial in the numerator. They are not factors. Okay, you cannot cancel the 3. You cannot cancel the x squared. Going back here to the fundamental principle of fractions, it says if you have a common factor, in this case k, you can divide numerator and denominator by k and reduce the fraction to lowest terms. Okay, it does not say anything about this. If you have, say, a plus k over b plus k, this is not a over b. Here, the k's are not factors. Okay, the k is added to the a, it is added to the b. Since they are not factors, you cannot divide numerator and denominator by k and get them to cancel out. Okay, not this. If everything is joined by multiplication, then you can cancel out the common factors. Now, somehow, people never want to do this with numbers, but they do want to do it with the variables. For example, if I gave you 23 over 60, and I said, try to reduce this to lowest terms if you can, or is this in lowest terms? I don't think anybody would say that this is, say, well, it's 20 plus 3 over 20 times 3. Everybody knows that. It's 23 over 60. But I don't think anybody here would want to cancel the 20s or the 3s. You understand that you can't do it. Well, you can't do it here. 23 over 60, by the way, does not reduce. There are no factors in common. You can't cancel the 20s and cancel the 3s and get 1s or whatever. Okay, you can't do it here, and you know it, but somehow you get confused with the variables. If you can't do it here, you can't do it here. Okay, x squared and 3 are factors in the denominator. They are not factors in the numerator. You cannot cancel out. Okay, so this is as far as you go on this one. This is as far as you go on that one. X squared minus 4 over x squared plus 2x. First of all, we cannot cancel the x squareds right off the bat here. They are not factors in the top and the bottom. Nor can we cancel the 2 into the 4 or something like that. 2 is not a factor in the denominator nor in the numerator. Okay, that doesn't mean you give up hope altogether on a problem like this. What you can do is factor the problem. Try to get things joined by multiplication, and then maybe you'll notice a common factor in the top and the bottom that you can cancel out. In this form, you can't cancel. But if you notice the top is a difference in squares, x squared minus 4, x squared minus 2 squared, you can rewrite the top as x plus 2 times x minus 2. You can rewrite the denominator. Now, the denominator happens to have 2 terms, and there's a common factor, x. You can factor out the x and be left with an x plus 2. Okay, the top is x squared minus 4. The bottom is x times x plus 2. By the distributive law, this is x squared plus 2x. That's what we have. Now, in this form, you notice that x plus 2 is a factor in the top and the bottom. It's joined by multiplication here in the top and in the bottom. X plus 2 is a factor in the top and the bottom. We can divide numerator and denominator by the same non-zero quantity, x plus 2, giving us a final answer of x minus 2 over x. And by the way, this is the final answer. Do not improve upon it. You cannot cancel the x's. X is not a factor in the top. Okay, so the x's can't be canceled. This is the form you leave the answer. Okay, let's try another example. x squared plus 12x plus 36 over x squared plus 8x plus 12. Okay, you've got to resist the temptation to go 12 into 36 or canceling the x squareds. Remember, the 12, the x squared, these are not factors. What you must first do is factor the problem and then look for things to cancel out. Okay, the top can be factored. What we're looking, remember the lead coefficient here is 1 and also here. So we can say on the top we are looking for two numbers which multiply to 36 and add to 12. And of course, plus 6 and plus 6 does that for us. You should always check by FOIL to see if you factored it correctly. X squared plus 6x plus 6x, that's the plus 12x plus 36. And on the bottom, we're looking for two numbers which multiply to 12 and add to 8. Okay, plus 6 and plus 2. And checking x squared plus 2x plus 6x, that's plus 8x plus 12. Now we notice that in the top and the bottom, x plus 6 is a factor. We can divide numerator and denominator by x plus 6 and get the final answer, x plus 6 over x plus 2. And that is the final answer. Don't put the 2 into the 6 or cancel the x's. That's as far as you go in this problem. Now what I want to do is review the rules for multiplying fractions and dividing fractions. And by the way, this is a review. If you'd like to see a slower treatment of these topics, I'd suggest you go back to the appropriate tapes in the elementary algebra sequence. Okay. Rule for multiplication of fractions. If you want to multiply two fractions, a over b times c over d, you multiply the numerators and divide by the products of the denominators. Okay, when you see AC, of course I mean A times C. BD means B times D. You multiply the tops and put it over the product of the bottoms. Okay, let's try an example. X squared y over 8z to the 4th times 2z squared over 5x cubed y squared. All right. Now, before you can do the multiplication straight off. In other words, multiply the numerators and divide by the product of the denominators. Very often it's a little easier if you first try to do some reducing, okay, and then do the multiplications. Okay, by the way, since eventually I will be multiplying all the tops together and dividing by the product of all the bottoms, it doesn't matter if, say, in other words, you have an x here and an x diagonally across here. You can cancel anything in any of the numerators with anything in the denominators, as long as you have factors. Any factor in the numerator, no matter on which part it is, can cancel any factor in the denominator, because eventually this is all one big top and one big bottom. Okay, so let's go to work on that. I look at the 2 and the 8. I say 2 divided by 2 gives me 1. It might be a good idea to actually do this and to keep sort of like a row on top of the fraction and on the bottom of your results. Now let's look at the z squared. We divide z squared by z squared, we get 1. Z to the 4th by z squared, and we get z squared. Okay, let's look at the x squared. X squared divided by x squared gives me 1. X cubed divided by x squared gives me x. And finally, the y's. Y divided by y gives me 1. Y squared divided by y gives me y. Let's see what we have. On the top, everything has been canceled out. We're left with 1 times 1 times 1 times 1. We have 1 on the top. Don't leave it a 0, okay? Sometimes people, in other words, don't put the 1 down. It's still implied there. If everything has been canceled out on the top, there is a 1 implied. Because what you've been doing is dividing the top by something. For example, if you have 4 on the top, you divide by 4, you are left with 1, not 0. On the bottom, let's see what we have. We have 4 times z squared times 5. This was not canceled, okay? Times x times y. So we have 20 xy z squared. One over 20 xy z squared. Okay, let's try another example. X squared y minus xy squared over x squared minus y squared times 4x plus 4y over x. Okay, now don't start forgetting the things that I've told you. Don't jump in and start canceling out x squared or anything like that. Remember, the idea is to factor everything as far down as you can and then look for things to cancel. Okay, notice in the earlier example I gave you over here, everything was factored to begin with. There were no pluses or minuses here. It was x squared times y over 8 times z to the 4th. Everything was factored. Here, okay, once we start bringing in the pluses and the minus additions and subtractions, we have to first try to factor it out. Try to get everything joined by multiplication if we can. Okay, on the top, in the upper left here, we have 2 terms, and there's a difference of 2 terms, and we see that they have a factor in common, namely xy. You can take an xy out, and you're left in the first one with x, and in the second one with y. Using the distributive law, you multiply and you see you get x squared y minus xy squared, which is what you have. On the lower left here, you have the difference in 2 squares, which we know how to factor. It's the sum of the numbers times the difference in the numbers. X plus y times x minus y. In the upper right here, we have 2 terms added together. There is a common factor. It's a 4. We take it out, leaves us with 4 times x plus y, which is, of course, 4x plus 4y, which is what we had there. And the lower right, we just have an x. Now let's see what we can cancel out, what factors the numerators and denominators have in common. The first thing I notice is that we can divide numerator and denominator by x minus y. X minus y divided by x minus y leaves you with 1 x minus y. Divided by x minus y. I said, now here it's very often people just, cancel out and leave the 1s out. That's okay. But should you wind up with everything canceled on the top, don't forget that's really a 1 there. Now, we can also cancel the x plus y's. Remember, you're allowed to cancel something in the denominator of this fraction with the numerator on this one. Okay. X, cancel the x here. And let's see what we're left with. On the top, we have y times 4, or 4y. And on the bottom, everything has been canceled. And of course, if everything has been canceled, there's a 1 there. 4y over 1 for a final answer of 4y. The last thing I want to do with you is to give you the rule for division of fractions. Okay, if we have AB, one fraction divided by another, AB divided by C over D. Okay, when we divide fractions, the rule is you invert the divisor and multiply. In other words, if it's AB divided by C over D, this is the divisor. This divided by that, you invert and multiply. And let me justify that for you. AB divided by C over D means, literally, AB here, divided by C over D. We usually write it this way. You'll find it this way in the book simply because it saves space. But what it means is this fraction divided by this fraction. Okay, now, it's perfectly okay to multiply numerator and denominator of a fraction by the same non-zero quantity. So let's multiply numerator and denominator here by d over c. It's like the k that we had before. In other words, I'm multiplying the top and the bottom by k, but it's in the form d over c. Now when I do it, look what I get. On the top I get A over B times D over C. And on the bottom, CD over CD, or the C's cancel and the D's cancel, giving me just 1. So I get AD over BC, AD over BC divided by 1, or just AD over BC, which is what I had here. In other words, to divide the fractions, you invert this one and you multiply. Let's try an example. X squared minus 3x over x squared minus 4x plus 3 divided by x cubed plus x squared over x squared plus 2x plus 1. And I would say the first thing to do is to rewrite this problem in terms of multiplication. Don't try to save paper or save steps, okay, and try to factor at the same time. I'm just going to rewrite it this time as a multiplication. X squared minus 3x over x squared minus 4x plus 3. Instead of dividing by this, I invert and I multiply. So I'm going to multiply by the reciprocal here. Now it becomes a multiplication problem, and all I have to do is factor everything as far as it goes and see if I can cancel factors in common, top and bottom. The top, x squared minus 3x, I see that the two terms have an x in common, x times x minus 3. This gives you the x squared minus 3x. Okay, in the lower left here, the lead coefficient is 1. It's a fairly easy factoring problem. I'm looking for two numbers which multiply to 3 and add to minus 4, and that's minus 3 and minus 1. There was no common factor that you could pull out, but you could just factor a trinomial by this method. This is x squared minus 4x plus 3. Okay, in the upper right here, okay, once again, there's no common factor in the upper right, but you can factor the trinomial, two numbers which multiply to 1 and add to 2, and that's plus 1 and plus 1, giving you x squared plus 2x plus 1. And in the lower right, there you do have a common factor, namely x squared, which can be pulled out in front, giving you x cubed plus x squared if you multiplied it out. Now that everything is joined by multiplication, we're going to see if we can cancel out common factors. We see the x minus 3's cancel. The x plus 1's, one of the x plus 1's on the top cancels one on the bottom. You have an x here and an x squared here. X divided by x is 1. X squared divided by x gives you x. That appears to be as far as we can go. On the top, we're left with 1 times x plus 1. And on the bottom, x times x minus 1. And that is as far as we go. The x's do not cancel. X is not a factor in the top. And that brings us to the end of the tape.